In this video, we're going to walk through the solution to the insert method of the node class. We'll first get started by setting up the method itself. So I expect to call insert with some amount of data to insert into our tree. Now we're going to use a recursive solution here. So we're going to start off at the root node, and then if we are not able to insert some new data at the root node, we'll then start to recurse through different nodes in the tree. So again, for example, on the value -20 right here, if we pass that to 10, then we need to decide one of four things. There's one of four things that's going to be true. First, if -20 is less than 10, and it is, we need to see if there is a value already assigned or a node already assigned to the left property here. If there is, then we should take the -20 and pass it off to that node. Otherwise, we should create a new node and assign it to the left value. So let's take care of that check to start. Back inside of my code editor, we're going to say if the incoming data value is less than this .data and there is already something assigned at the left property, then I don't want to do anything else with this. I want to delegate the insertion of this new piece of data off to the left-hand node, the node that already exists to the left-hand side on my tree. So to do so, we'll call this .left. Remember, this is a reference to the node that is on the left-hand side, so it is an instance of the node class. So to recurse through this, to make sure that we tell this left node to take care of inserting this piece of data, we'll call insert on that and pass in our data. Next, we'll handle the other case, the case in which this .data is greater than data, but we do not yet have a left node. So if data is less than this .data, then we want to create a new node and assign it to the current node's left property. So that will handle the case in which we eventually recurse down to this -1 down here. For -1, we will notice that the left-hand side has no value assigned to it. So that node will fail the this.left check right here. And in that case, we'll want to create a new node and assign it to this.left. So else if data is less than this, data is less than this.data, then we will say this.left is a new node that's going to contain data, like so. Okay, so that essentially handles the left-hand side, and we're now going to repeat the exact same thing for the right-hand side of our tree as well. So on the right-hand side, let's say that we're working with a value of -120 over here. We want to look at the right-hand side of every node, and along the right-hand side, we want to see if a node already exists there. If it does, we'll pass this new value off to the insert method on that node. Otherwise, we will create a new node and assign it to the this.right property. So back inside the insert method, we're still going to chain on some else if statements here. So we're now going to check to see if data is greater than this.data and if there's already a right-hand node assigned. So if there's already something there, then we're going to delegate the insertion of this new piece of data off to that right-hand node. So we'll say this.right.insert data. And then the final case we need to worry about here, we'll say else if data is greater than this.data. So this will handle the case in which there is no node available on the right-hand side. So in this case, we'll assign to this.right a new node that contains data, like so. All right, let's check our tests out and see how we're doing. So back at the test runner, it looks like we are able to insert nodes correctly. Cool. So that's pretty much it for inserting nodes onto a binary search tree. Again, this is probably one of the core questions that you might end up seeing around binary search trees, but there are a couple of other common questions that you might see as well. So let's continue in the next section, and we'll take a look at one or two other common questions you can expect around binary search trees. So I'll see you in just a minute.